All right, so let's turn our attention into the interior of the Earth. Seismic waves. Earthquakes produce energy, which are then transferred through the Earth as seismic waves, right? Both pressure and shear types of waves. Okay. Pressure, also known as primary waves or P waves, travel through anything. Liquid, gas, solid, I don't care. It travels through it all. Shear waves, on the other hand, can only travel through solid. Can't travel through liquid, can't travel through gas, only solid. And the speed of the wave actually depends on the density of the stuff that it's going through. I wanted to say the rocks, but that's not always true because it could be liquid or gas depending on the type of wave. So here's kind of a picture of what's going on. Okay, the P wave's the green one on top, and it's kind of like you're pressing and expanding a slinky. That's a pressure wave. Now the other wave is a shear wave, where you go up and down. All right, so we can use the fact that the densities change, or sorry, the speeds change depending on the density, and that there's P waves which go through anything, and S waves that can only go through solids to figure out what's inside our Earth. So if an earthquake happens, then the P waves can travel in all directions throughout the entire Earth through anything. So we can get P waves all the way around the Earth from this one earthquake. The S waves, on the other hand, cannot travel through liquid. So there's actually a shadow where there's no S waves. And this kind of indicates that the outer core might be liquid. All right, so using the information from the P and S waves that we could get, we've determined that the Earth's mantle is less dense than the core. So the mantle we know is rocky, or we think we know, and the core therefore has to be metallic. We actually think it consists of iron and nickel alloy. Now there's two parts to the core, the outer and the inner. The outer core is liquid. The inner core is solid. We think it's solid not because it's cooler, but because there's so much pressure from the outer core and the mantle and the crust, making it a solid. And then lava comes from the mantle, which kind of allows us to say, okay, yes, in fact it is rocky, and gives us an actual analysis of what's in there. Now the moon do have, I want to say earthquakes, but technically they're moonquakes. However, they're kind of weak. So it does have them, and we can pick them up. So we can pick up the S waves and the P waves. And when we look at it, we figured out that yes, it does have a core, a mantle, and a crust. The density is about the same, right? And so the speed of the wave gives us the density. The density is about the same. However, they are chemically different. So again, you kind of want to live on the moon right now because it's just like, oh, okay, yeah, same density, same stuff, maybe a little bit different chemically.